Hello, this is Ms. DB, and in this video we're going to review how to factor trinomials or quadratics. So this should be a review from Algebra 1, like the last assignment was, but this one you might need to practice a little bit more. So we're going to also look at factoring special products, like the product of the difference of squares and such, and perfect square trinomials. All right, so we have here an example of how to factor x squared plus bx plus c. There's if c is positive and b is positive, then both factors are positive. If c is positive, the last term, and b is negative, then they'll both be negative. So we'll start with this kind, and then we'll look at what to do if c is negative. So here's an example, x squared plus 7x plus 10. They're both positive. All the terms are positive, which means that in our final answer, both of them are going to be positive. When I do this, I usually write my two sets of parentheses first, and then I put my x and my x in, because x times x is x squared, so we know we're going to get that. And then I think to myself, what are the factors of 10? I have to pick the factors of 10 that when I add those factors, I get the middle term of 7. So 1 times 10 is 10, but 1 plus 10 is 11, so that doesn't work. The other factors of 10 are 2 and 5. And when I add 2 plus 5, I get 7, which is the middle term, which means that I should use the 2 and the 5 as my factors. So now I factored this as x plus 2 times x plus 5. Now we're going to check this. We check by foiling our answer. So here's a review of foiling for those of you who have forgotten how to multiply two binomials together. So the F stands for multiply the first term times the first term. The O stands for the outer times the outer. The I stands for the inner times the inner. And the L stands for the last times the last. So let's do that with the one that I just did. So I had x plus 2 and x plus 5 as my two factors. I'm going to FOIL this and make sure that I get what I started with. So x times x, first times first, is x squared. The outer is x times 5. That's 5x. You can write x times 5, but we usually put the coefficient first. The inner is 2 times x. And then the outer is 2 times 5, which is 10. And then you add your like terms, which is the 5x plus the 2x, and you get x squared plus 7x plus 10, which is exactly what we started with, so we factored it correctly. It's a very good idea to take the time and check your factoring by foiling, and you will get good at that so that you'll be able to check it in your head as you go. But at first, write it down, and you can check it on a piece of paper. You don't have to turn that part in, but then you'll get the problem right if you checked it and you checked it correctly. All right, next one is factor x squared minus 9x plus 18. So I'm going to set up my parentheses and put my x and my x in there, because I know that x times x is x squared. And now I have to look at the 18. So the factors of 18. Now because this is a negative, I'm also going to look at, I could use 1 and 18, but that would give me a positive 18, right? Or I could use negative 1 and negative 18, which also gives me a positive 18. So I could use the negatives as well. In fact, I have to use the negatives because I need a negative 9 for my middle term here. So negative 1 times negative 18, that does equal 18, but when I add those, I get negative 19, and I want negative 9. All right, other factors of 18 are 2 times 9, or negative 2 times negative 9. But when I add those, I get negative 11, so that doesn't work. And then the other factors of 18 are 3 and 6, or the negative of those is negative 3 and negative 6, because negative 3 times negative 6 equals 18. And when I add those, I get negative 9. That's the one I want. So I want to use these, so I put in the minus 3, negative 3, and the minus 6 for the negative 6. And then I check with FOIL. So when I check with FOIL, I am going to go first times first is x squared. The outer would be x times negative 6, which is minus 6x. And the inner is negative 3 times x, which is negative 3x or minus 3x. And then the last times the last is negative 3 times negative 6, which is a positive 18. And then our middle terms is negative 6x minus 3x, which is indeed a negative 9x. So it does work. It's exactly the same as what I started with, so I know that I did it correctly. Now it's time for you to do these problems. The first couple have the steps written out for you and even the factors written out for number 1. So let's start with number 2. Number 2, we need the factors of 20, that's where the last term goes there, that sum to the middle term of negative 9. Make sure you take the sum or the sign of the middle term as well. So because it's a negative 9, I mean, I could start by saying, well, 4 and 5 are the factors, and that equals a positive 9, but I need a negative 9, and I still need to get a positive 20. So I can't make one of them negative because then I'd get a negative 20. So let's try negative 4 and negative 5. So when you don't have to list all the factors if you know which one it's going to be. This is the one that works, so I don't have to keep going and say, well, let's try 1 and 20 and 2 and 10. You don't have to do that if you find the one that works. So that means that I'm going to have these should both be minus, so change that on your worksheet, x minus 4 and x minus 5. And I'm going to check this by foiling it. So I'll do that over here. X minus 4 times x minus 5. And let's make sure we get the right answer. And don't make your check equal the right answer without really doing the work. So first times first is x squared. Then I have x times negative 5. That's the same as minus 5x. Then I have the inner times the inner would be minus 4x. And then the outer times the outer would be a plus 20 because negative 4 times negative 5 is plus 20. So then you add your two middle terms will be the like terms, and I have negative 5x minus 4x, that's negative 9x, and then the plus 20. It checks. It's exactly the same as what I started with. I can see that. So then that means that these factors are correct. Now what if I had left that plus there, that typo there, and had x plus 4 and x minus 5. Then when I FOIL it, I am going to get the wrong answer because it's wrong. So I'd have negative 5x for the outer, and I'd have plus 4x for the inner, and then I'd have minus 20 for the end. When I combine my like terms here, I would get negative 1x, and then I'd have minus 20. This does not match this. This is wrong. So then I would know that this is not the answer. I made a mistake, and I'd go back to the drawing board and revise and try to see what's wrong. So the checking part, you don't automatically make it work. You need to make sure that you got the right factors and have the problem correct. All right, so then you have several problems to do practicing this. And then we're going to talk about what to do when the last term is a negative number. So if C is negative, that means the last term is negative, and B is positive, then the larger factor must be positive. If you have a negative and the other term is also negative, then the larger factor must be negative. So let's look at some examples. If we have x squared plus 8x minus 20, we are going to do basically the same thing. We're going to find the factors of negative 20 so that when you add the factors together, you'll get a positive 8. So one of these has to be negative. So we could do negative 1 times 20, but when we add that, we get 19. We could do negative 2 times 10, which gives us our answer. Now, what if I had written down 2 and negative 10? When I multiply that, I do get negative 20, but if I added these two together, I would get negative 8, which would not be the correct one. So the hint is that if you know that this is a positive middle term, then make the smaller ones be the negatives, the smaller factor be negative, because then when you add them, you'll get a positive number. And when you find the factors that work, you don't have to keep going and list all the other options. You can use those then. So because this is the one that worked, then in my parentheses, I would have the x and the x already filled in. I'm going to use the minus 2 and the plus 10. And then you check this with foiling. So you go first times first is x squared. It's important to check because it's easy to make a mistake with these negatives. This would be a positive 10x, and the inner would be a minus 2x. Then I'd have negative 2 times 10 for the last, which would be negative 20. And we combine our middle terms for our like terms, and we do get the positive 8x like we wanted, and the negative 20 for the end. So it works, it checks, we did it correctly. All right, let's look at the second example. We have x squared minus 3x minus 28, and we're going to find the factors of negative 28 that will add up to be a negative 3. So what are the factors of negative 28? Well, I could do negative 1 and 28, but that would add up to be a positive 27, so that doesn't work. I could do 1 and negative 28, but that would be a negative 27 when we add them, so that certainly doesn't work. So let's try some other factors. We could do 4 and 7. Now I know that I need a negative here, so let's put the negative on the larger factor. Then when we add them, we'll get our negative 3 like we wanted. So we found the right factors, and then you're ready to fill in your parentheses, x, and then a plus 4 because that's a positive, and a minus 7 because that's the negative. And then we check with FOIL and make sure that it works. So x times x is x squared, minus 7x for the outer, plus 4x for the inner, and then minus 28 for the last times last. And this is going to work. I'm going to get a negative 3x when I combine my like terms. So if that matches this, then I know that I have the right factors, which here, they're right there. So on your worksheet, again, there's a couple of them that are partially filled in, and then there's a few problems to practice on your own. Let's do number 10. So I know I'm going to have an x and an x in my parentheses. Let's find the factors to use. We are going to look for the factors of negative 14 that will add to a negative 5. So this is the product. We're looking for the factors. What times what equals negative 14? Well, 2 times 7 is 14, but I need a negative 14. So I could do negative 2 times 7, but when I add those, I get a positive 5. Nope. How about 2 and negative 7? Then when we add them, we would get negative 5, and that works. So now I know that I'm going to put a plus 2 here and a minus 7 here. And then what do I do next? I check it. So first times first is x squared. The outer is negative 7x. The inner is plus 2x. And then the last times last would be negative 14, just like I wanted. And if I check this by adding the like terms, I see that I got exactly the same thing. So my answer is x plus 2 times x minus 7. All right, now we're going to look at the special product ones. Sometimes if you recognize that you have a special product, like the difference of two squares, then it can make it really easy to factor. So if we started out multiplying a plus b times a minus b, the middle term cancels. For example, let's just do x plus 2, x minus 2. So when we FOIL this together, we'd get x squared minus 2x plus 2x, and then 2 times negative 2 is minus 4. These two would cancel because negative 2x plus 2x is 0, so I could just write this as x squared minus 4. What we're going to learn is how to go backwards and factor x squared minus 4 into its two factors. The way you can recognize a difference of two squares is when there is no middle term. And both the first and the last term, there's only going to be two terms, are a perfect square. So 4x squared is a perfect square because 4 is 2 times 2 and x squared is x times x. 9 is a perfect square because it's 3 times 3. So if you have this, if you have the difference of two perfect squares, it has to be a minus sign, cannot be plus. Then you can use a shortcut way to factor this as a plus b times a minus b. So let's look at some examples. There's two examples here. In the first one, there's no number in front of the x squared, so it's just x and x, and then 81 is a perfect square. So we have a perfect square minus a perfect square. So this is going to factor as x plus 9, x minus 9. But something like b is a little trickier. You have to figure out what is the square root of both of them. So 9p to the fourth, that would be 9, the square root of 9 is 3, and the square root of p to the fourth is p squared. If you have an even number exponent, cut it in half to find what it would be, what its perfect square root would be. And then the 16q squared, that would be 4q squared, and this is 3p squared. So that's really what we have for this one. So when we write it this way, we can see that our factors are going to be the first one plus the second one, and then the first one minus the second one. So let's find a tricky one here. Yeah, it's not super tricky, but let's look at, this is a different problem. I'll fix it on the worksheet before you do it. So let's look at 12. That would be 10x squared, because the square root of 100 is 10. The square root of x is x, minus the square root of 16 is 4 squared. So when you write your two sets of parentheses, you're going to put the first one, 10x, minus, or you can do plus or minus in either order. And then the other one will be 10x minus 4. And we can check this by FOIL, just like we did before. So 10x times 10x is 100x squared. And then we have 10x times negative 4 would be minus 40x. And then the inner would be 4 times 10x, which is a positive 40x. And then the last times last would be minus 16. These cancel because we have negative 40x plus 40x. So we end up with 100x squared minus 16, which is indeed what we started with. And then we have a perfect square trinomial. Sometimes these are, if you recognize these, then there's a shortcut for factoring this as well. Sometimes they're a little bit harder to recognize. But if the first term and the last term are perfect squares, and the middle term can be found by taking 2 times the square root of this times the square root of that, then you have a perfect square trinomial. And they can have, the middle term can either be positive or negative. This is especially helpful if you have a number in front of the x squared term, because factoring those is difficult. So if you do have a number in front of the x squared term, check and see if you have a perfect square trinomial. And if you do, then you can use these shortcuts to factor it. So let's look at number 15, because it has a number in front of the x squared term. So this one would be tricky to factor if it's not a perfect square trinomial. So to see if it is, this has to be perfect square and this has to be perfect square. Well, they both are, because the square root of 4 is 2, the square root of x squared is x, so that's a perfect squared. And let's write the last term as a perfect square too. That's just 5 squared. So if the 2x times 5 times 2 is equal to the middle term, then we have a perfect square trinomial. So this would be 2x times 5 is 10x. And if I multiply that by 2, I would get 20x. Those match. So therefore, I do have a perfect square trinomial. So I can use this rule that says, let's see, I had both are positive. So I'm going to use this rule here. I can rewrite this as a plus b times a plus b. Or you could write it as a plus b squared if you wanted. You don't have to. So a being this and b being that. So this is going to be 2x plus 5 times 2x plus 5. If you want, you can write that as 2x plus 5 squared, but you don't have to. Now what am I going to do? I'm going to check it. So I'm going to check it with FOIL. So I take the first times first. 2x times 2x is 4x squared. Now the outer. 2x times 5. 2 times 5 is 10, and then I have an x. And the inner. 5 times 2x. 5 times 2 is 10, and I have the x. and then the outer 5 times 5 is 25. So I get 4x squared, 10x plus 10x is 20x, plus 25. And that is exactly the same as the quadratic I started with, so it checks and we have the correct factors. This is the answer right here. All right, one more little piece here, and that's putting this together. Here's a checklist for factoring polynomials. The first thing you should do is check and see if you have a greatest common factor. Then check and see if you have a difference of two squares or a perfect square trinomial. If you do, you can use the shortcut. And then these are a review of how to factor trinomials. This one we didn't talk about, but it's a little bit trickier, but we can go back and look at that. I'll put a resource in your folder for how to do those. And then when you're all done factoring, just double check that you don't have any more common factors. So there's a few problems at the end where you're going to put everything together that you've learned. Let's look at number 20. So first check and see if you have any common factors. And we do. We have a 5. Always check and see because it can make your problem a lot easier. So there's a greatest common factor of 5 in every one of these terms. So remember in the first factoring review, we looked at dividing each of these terms by 5 to find what goes in the parentheses. So we'd be left with m squared minus 5 divided by 5 is m, or 1m if you want. And then 60 divided by 5, you can double check that, but it's 12. So now we're going to factor what's left because we can. I'm going to put the 1 in there. So I'm going to look for the factors of 12, negative 12, that would equal a negative 1 when I add them. So the factors of negative 12. So I could do negative 12 times 1. That would be negative 11. That doesn't work. I could do negative 3 times 4, but that would give me a positive 1, but I'm close. So let's put the negative on the 4. So 3 plus negative 4 is negative 1, and that's what I wanted. So these are the factors to use. So that means a plus 3 and a minus 4. And then don't forget the most important step is to check. So I'd have 5 times m squared. The outer would be minus 4m. The inner would be plus 3m. And the last times the last would be minus 12. And then we add our like terms. Do I have enough room here? A little bit more room. Okay. That would be minus 1m minus 12. Now I multiply the 5 back through with the distributive property to see if I get this. So that'd be 5m squared minus 5m, and then 5 times negative 12 would be minus 60, which is exactly what we started with. So then this right here is the correct answer, the correct factor. All right, well, there's a lot to this worksheet. Let me know if you get stuck or if you want to work on it together. Thanks a lot and have a wonderful day.